All right,
I
cool.
suppose you would want to share slides, so you can just, I can
Yeah, let me
actually,
just share my screen. I think you need to disable sharing or something before
there
I
you
can
go.
share mine. There we go. Let me see if it works now. Uh,
Just a second call for Olivia, Ken, Hank, new joiners. Any one of you from the Keystone Project?
No, I'm not.
No.
No. Okay. I'll have another call when Alec finishes his presentation. Go ahead, please. You're on mute, Alec, I think.
this will probably be even less interesting if I go off mute. Just let's keep this interactive, okay? I see Fritz and Nathaniel, you guys are responsible for a lot of what I'm going to talk about today. So if you have
Does this mean we
questions,
get to, does this mean we get to heckle?
absolutely. In fact, I would encourage it. And Dan's not here to maintain decorum, so we can, I mean, when the cat's away. So feel free to jump in, add commentary as you see fit. Let's just get in. First off, the reason we started with this whole confidential computing thing was to encrypt data in memory. And when we first started with SGX enclaves, two of the big attack vectors that we talked about were two. One, in a public cloud situation or in a situation where you don't have complete control over access to your machine, anybody with admin access to the machine that was running your VM could gain access to your memory. So administrators, and of course, in public cloud situations, the cloud administrator could gain access to your memory. And we were trying to figure out a way to protect memory from those kinds of exploits. And then the other kind of attack that we were worried about was physical exploits. And back in those days, we talked about the cold boot attack, where somebody would come in and physically remove memory from the machine and keep it cold, put it in another machine, and they were able to access the memory contents. Since those days, kind of cold boot attacks and physical attacks of any sort have gone out of scope. We now readily admit that we rely on the person who is in physical possession of the machine to provide physical security of the machine, so that nobody can peel the cover off a machine and yank out the memory chips or install an interposer. But the other attack, where somebody who has admin access of the machine, is still the one that we're trying to protect with confidential computing. And the way we've done that historically is to use a bounce buffer. And I've just got a blow up of what that looks like. And so we've got a confidential virtual machine, and this is running in memory that's protected from the administrator. And it's got two banks of memory. Basically, it's got private protected memory that is either encrypted or isolated using address-based isolation from the administrators and from the host machine. So this memory here just can't be accessed by the host machine. But that introduces a problem, which is if you want to interact with the outside world, for example, to write data to the network or to store data on a file system, well, you have to interact with the real world. So it's a two-step process. You copy memory from your private protected memory locations into a shared memory locations. We call that a bounce buffer. And so you bounce your data into this bounce buffer. And in the bounce buffer, it's not protected. The outside world can get access to it. And that's how the devices write it to, for example, the network interface card, where it then flows out to network and storage. The problem with this is it slows things down, right? You can't do direct memory access. It's much easier if you can just have those devices that interact with the outside world quickly move the data straight into your protected memory so that you can do computations on it and not have to work through this cumbersome bounce buffer. Um, so that's the problem with confidential computing and what puts limits on performance. And now we're going to talk about some ways that we're trying to overcome it and what it means in terms of attestation. All right, so attestation in the early worlds where you just had a CPU in your confidential virtual machine was pretty simple. You had an Intel CPU, an SGX CPU, and you had an SGX enclave. that was able to interact with that CPU, and any memory that was written by this SGX enclave, as we've just discussed, was protected. It's private, so the hypervisor couldn't get access to it. So as long as you knew your SGX enclave was sound, then you knew you had good security. The only thing that you needed to attest was this SGX enclave, and it was attested by the general purpose CPU. So the enclave would request that the CPU produce attestation evidence, and that attestation evidence was pretty simple. It was basically a security version number and some Intel claims. Very simple. When we talk about attestation, there's some questions that comes up. Who provides the evidence? Who guarantees that the evidence is genuine and wasn't tampered with? Who sets the standards for what the golden value is, the reference value for the SVN? For example, we know that SVN version 4 had a critical security bug, but version 5 is fine. Who decides that version 4 is good? Version 4 is compromised and version 5 is good. And then who judges the evidence against these reference values? Who owns the code that judges the evidence? And who relies on that judgment to decide whether the T is trustworthy? Now, I'm going to introduce some RATS terminology here. So the person who provides the evidence is the attester. The person that guarantees that the evidence was genuine is called the endorser. They endorse that the evidence hasn't been tampered with. Who sets the standard? What's a good golden value and what's a bad one? That's the reference value provider. Who judges whether the evidence is good? Who actually weighs the evidence against the reference value and decides whether it's trustworthy? That's the verifier. Who owns the code that does the judging? The verifier owner. And then who finally gets all of this judgment and decides whether they're going to trust the T? That's the relying party. So how does that look in the RATS diagram in the world of SGX? It's pretty green, and that's what I want to draw your attention to, in the sense that the cloud service provider is pretty much out of the picture. And we really put a lot of emphasis on that in the early days of confidential computing. The evidence endorser, the people who sign the attestation evidence to make sure it hasn't been tampered with, as the hardware manufacturer. And in those days of SGX, it was Intel. Who provides the reference values? Again, it's Intel. They're the ones that decide whether their firmware was at the correct version number. Who is the attester? Who provides the evidence? Again, it's the Intel CPU and their firmware. Who verifies that the evidence is okay? Well, you could use a cloud verification service, an attestation verification service, for example, Microsoft Azure Attestation, or you could use your own, or you could use Intel Trust Authority. So if you used Intel Trust Authority, again, there's no cloud service provider involved in this so far. The relying party owner was the person who's running the enclave, and the relying party was the enclave itself. So this is how we kept the cloud service provider out of the attestation flow. And this was great if you could live with the limitations of an SGX enclave, which is pretty small memory space and the cumbersome nature of having to move all data through a bounce buffer. In CVMs, once you get out of the world of enclaves and you try and bring a whole VM into the picture, the world gets a little bit more complicated because you've got this paravisor in the case of Azure, and you've got other pieces of the TCB, the trusted compute base. For example, the VTPM in the world of Google, or in the world of AWS, you've got the hypervisor. There are other pieces that the cloud service provider brings into your TCB that if you're going to be confidential computing, those things have to be measured and attested. So now all of a sudden, the attestation evidence is coming out of this paravisor, and flows into your attestation report. And if you look carefully, you'll see that there's pieces of this attestation evidence that are provided by the cloud service provider. Since I'm a Microsoft employee, I'm going to focus on the Azure pieces here. Um, Azure provides pieces of attestation evidence that you need to verify to show that the TEE is trustworthy. How does that look in our RATS view? Hang on, I'm stuck here. Here. Now all of a sudden, part of the evidence that is provided in attestation is provided by Microsoft. You've got the HCL measurements and you've got UFI measurements that are in here, in addition to the measurements that are provided by the CPU manufacturer. You can still write your own verification service, but the values that are provided into that verification service, the reference values, the golden values, are kind of provided by Microsoft, right? Only we know if our HCL measurements are trustworthy or if they're not trustworthy. So pieces of the cloud service provider are coming into the attestation evidence and they're coming into your TCB. The thing I want to stress here is, according to the Confidential Computing Consortium, if these pieces of attestation evidence are generated in hardware, right, things that can't be tampered with, and we provide an endorsement that shows that the evidence hasn't been tampered with as it was being transmitted through the cloud service provider infrastructure, then it's still confidential computing. It's still a hardware-based, a tested, trusted execution environment. So in the world of confidential VMs, it's still kind of simple. You've got all hardware provided by a single provider, either Intel or AMD, soon ARM, and some software pieces that are provided by Microsoft. They all provide hardware-based attestation evidence, and the same kind of flow as with SGX still applies. So then we go to the next slide. Now things get a little bit more complicated, right? Because instead of having a single CPU and a single CPU manufacturer, now you've got a GPU, probably NVIDIA. I'm just going to pick on NVIDIA here because they're a common provider of GPUs. And plus, they're members of the Confidential Computing Consortium. So now we've got a GPU and a CPU, both providing the attestation evidence, in addition to the software pieces that are in the stack, the paravisor that's provided by Microsoft Azure. If we take a look at the RATS roles, again, things are starting to get a little bit bigger, right? Nathaniel, I want to give a shout out to you here because you're the one who kind of introduced me to the fact that TSMC is in your TCB, right? So what I want
It's
to
not just TSMC. Anyone who's producing a chip is going to have a list of vendors that they're gaining IP from, right? So it's quite larger than just
AMI,
TSMC.
for example. So I think I just want to call out that in the early days of confidential computing, and we wrote a lot of the Confidential Computing Consortium docs back when the TEE was largely controlled by a single CPU vendor. It's getting bigger than that now, right? We've got the CPU vendor in there, the GPU vendor in there, the actual silicon foundry in there, and the kind of the village of people that are helping produce that silicon, they're in there as well. And they're also providing reference values, right? Only NVIDIA knows what the good reference values are for their firmware. The CPU vendors, Intel, AMD, know what the good reference values are for their CPU and firmware. The cloud service provider, if they've got pieces in the TCB, they have to provide good reference values, measurements for what is good firmware, what is bad firmware, what's outdated and has security vulnerabilities, and what doesn't. Once you start having the cloud service provider provide reference values and the GPU vendors provide reference values. Today, these aren't all in the same format. So when the attestation evidence comes out, it's not in a generalized format. So now if you're doing the verification, if you're evaluating the attestation evidence against the reference values, you kind of have to know what the formats are. So instead of being able to write your own um, verification service, attestation verification service, you're kind of having to rely on the cloud service provider to provide that verification service because only they understand the formats that the evidence provided in. So as a cloud service provider, Microsoft, we're working with the Confidential Computing Consortium and we're making sure that the all of the evidence that we provide is using open source standards, OCP and SAFE and so forth. And all of it is hardware based. And so it meets the definition of the Confidential Computing Consortium, but you can't say that Microsoft isn't in the TCB anymore. So I just want to continue to call that out. Not only do you rely on the cloud service provider these days to provide physical evidence, but you're relying on the cloud service provider to provide trustworthy reference values and then to fairly evaluate the evidence against your policies to see if things are actually trustworthy. The next thing we're going to add into
Hey,
the TC,
Alex,
yeah,
quick question. It's Manny. Can you go back to the previous slide? Yeah, something I don't understand is when you said that you cannot have your own verifier anymore because only the cloud service provider understands the formats of the evidence from the different, evidence producers, the attesters. Why is that the case?
it's because we don't have any agreed upon standards for delivering attestation evidence. It's such a dynamic world right now where NVIDIA comes up with a new chip or a whole new platform. We're seeing GB200 and Vera Rubin coming out. As soon as those chips are on the market, there's a ton of commercial pressure to make those servers available to our customers. We just haven't had the time it takes to come up with open um, protocols for exchanging attestation evidence and open formats. Yes, we do have the EAT, the Entity Attestation Token, but folks aren't adopting that stuff fast enough for us to be able to make it open so that customers could adopt it and read our documentation and write their own verification services in time. It's just
So,
it's
yeah,
on
so
the roadmap, but it's just not being done in time to give customers a realistic opportunity to write their own verification services.
okay, so it's not a technical limitation or
No,
a topology limitation. It really is a speed to market, reality.
that's exactly
Um,
right. I mean, those bits are out there. And if you had access to the format and you could, parse those bits and figure out where all the reference values are, you could do it yourself.
yeah, except that Microsoft would not support that because you would have to make that possible, right? But you removed the customer provided option in that verifier box there. So I assume you guys are not supporting or enabling other companies to do that today?
That's right. I mean, that doesn't stop you from verifying the bits that are produced by Intel because they're still using the same formats that they were using earlier on. And I see
For
Scott's
sure.
on the phone here. He can correct me if I'm wrong, but I haven't heard them talk about changing the format of the attestation evidence.
For sure. Okay, so the Intel thing is clear, but it is really for these newcomers, right? The NVIDIA chips in particular, I guess, that it's not possible yet, but eventually it should be. Yeah,
That's right.
got
I
it.
think that the North Star is definitely to make all this stuff open and transparent. And that's why we're members of OCP and that's why we're
Yeah, yeah,
working
yeah.
with standards bodies. It's just happening too fast.
I understood. I'm not complaining. I'm just, I just wanted to reassure myself that it's not a technical limitation or a
No,
topology limitation. It's just a speed to market reality.
That's exactly right. But there's one other thing that kind of we all need to think about, and that is if Microsoft is providing the reference values, right? And Microsoft is providing the attestation evidence, and Microsoft is endorsing the attestation evidence, what you'd basically be doing is you'd be taking some attestation evidence, you'd be verifying that the signature was right using a Microsoft certificate. You'd be comparing values provided by uh, Microsoft or NVIDIA, and you'd be looking at evidence provided by Microsoft or NVIDIA, and you'd be saying, does Microsoft's evidence agree with their reference values? So it's a good way to kind of double check that everybody is saying what they're saying publicly, but you're really relying on the hardware manufacturer to provide the evidence, endorse the evidence, and provide good reference values. So just checking the math yourself is a good double check, but you're still trusting the providers a lot.
Understood. But for instance, in the hybrid deployments where it's across multiple clouds or there's on-prem or edge, right? Having the capability of verifying yourself, even if when you fall back to the cloud service provider, you essentially have accepted that you trust the cloud service provider, but having a customer managed or a third-party managed attestation verification service does cover the cross, cloud and edge and on-prem deployment models.
Absolutely. Great points. Cool. Any other questions here? I can't see hands, so you guys will just have to speak up a little bit.
There are
I
hands.
raised my hand.
Oh, sorry about that.
Yeah. Yeah, hi, this is Hank. I'm not entirely sure if this is the right time, so I might be too early with my bulk of comments. But yeah, so the core problem is aligning with the speed of the to market challenge. Okay.
Well, hey,
and
hang
now
on. Let me get through one more. Let me get through one more slide, and that
okay.
way we can get the whole
And
bundle
then we
out on
can
the
do that.
table. Yes,
Got it.
because this next slide is everything, right? The next slide is it's essentially the same slide. I just want to introduce this picture. So now in the confidential VM, you've got the stack here running on the general purpose CPU. You've got the GPU card over here doing GPU stuff, right? And now to reach the outside world, to get to the file system backend and to get to the network backend, you're going through Azure Boost. If you do not want to use bounce buffers, and we don't want to use bounce buffers, right? Because you want this Azure Boost card to have direct memory access into the CVM's private memory, right? So when the data comes flowing either from the GPU or these boost cards at 600 gigabits per whatever, that doesn't have to get squeezed through a bounce buffer to get into the private memory of the CVM. All these massively fast peripherals can directly access the private memory of the CVM. In order to do that, they have to be trustworthy, right? They have to provide hardware-based attestation evidence, and they do. They do it through TDISP, right? And they encrypt the connections through SPDM. But again, these guys are providing attestation evidence. These guys are providing attestation evidence. Each of the three pieces that are in the TEE are providing attestation evidence. They're providing endorsements, and they're providing reference values. And so if you go to the DICE thing, now we've got more stuff in our RATS roles providing attestation evidence. So that's pretty much my whole presentation. So now's a good time to start talking. So go ahead.
Okay,
Sorry.
I don't know what's first. There's a sequence of hands, I assume, which I can't see right now.
I wish I could see the sequence of hands.
I'm on top. Okay, wonderful. Yeah, I found it. Okay. So yeah, speed to market, evidence formats, it's a hassle keeping up with that. Understood. TDISP might make all this more performant and put it tightly together. Understood. So from the point of the CSP, I will end with the question passport model versus background check model. Why? A verifier can be a co-commodity to a confidential compute service. I want to say a CVM, CV something. The confidential compute product by the CSP. And now you provide that service, the product. And that comes with a commodity that is a set of reference values and endorsements that have to be okay for your part of that trust domain. The housing center might different hardware. You buy the cheapest of the quarter, and it might always be different, but you know what's there, so you can provide as the CSP the fragmented and well-defined, for example, with quorum, the endorsements and reference values. But now it's very important to hear the question or the answer to the question: who owns the verifier? So one option, of course, is that the CSP also provides the verifier as a service, and you get the attestation result from the CSP. Now you have to trust the whole CSP CC service provider again. Another option would be to provide the verifier as an open source component that you can look at, I don't know, audit if you want, right, as an option, and compile. And then you can get the evidence from the CSP. You can get all the reference values and the endorsements from the CSP with some control of its composition, and can see how it all works together openly, and get an attestation result. And can see, okay, that's the attestation result Microsoft gives me also from their service. It's the same, right? So it doesn't matter who owns the service if you can show with an open source option of the verifier and get all the stuff hauled through the customer, basically, who wants to check it themselves, that you actually are doing and saying what you're trying to do. The small problem here is a paravisor, which is a thing that you kind of let in your secret vault, but it's not from you. So that is like a little bit of a tricky thing. It becomes its own attester somehow. And if that is also open source and you can check what it's doing, then you have a relatively good basis for trust here if you make all of that transparent. And I think that's where the decision might have to be made. Do I do one or both? Either the passport model or the background check model. If I go with the background check model, I, of course, offload the duty of all the appraisal, building the verifier from open source, checking the paravisor from open source and all that. But then you are really trustworthy because of the transparency. And if then this always aligns with the as a service version that you also provide as a passport model, then there can be trust over time, and you establish this trust, and you don't have to scale everything with your own verifier, and you can use a more scalable verifier from the CSP. But I think the main strategy I'm trying to promote here is starting with being open source on the verifier and with the paravisor, and ship that to the customer so they can check and look at it themselves, create the exact same attestation result as if you would do it as a service. That is creating trust. And yeah, that's my comment.
Great comment. Thank you. I'll say, just you called into the question whether a paravisor is open source. The paravisor in Microsoft Azure is open source, OpenVMM. So we've got that, but we're still going to have to talk about who provides the reference values and who endorses the reference values. And we can talk about transparency at the end. But those were great comments. I'll go to Nathaniel. I got my screens finally where I can see who's in line. Nathaniel, I think you were next. I'm not sure if it was you or Jens.
I think I'm next. I'm going to apologize preemptively because someone came to my door while Hank was speaking. So I might retread ground because I didn't hear everything he said. I suspect that he said, by the way, I want to point out, I'm going to make some criticisms here. These are entirely friendly because we're all friends here. And I have to make an obligatory plug, though, which is that in the second half of this year, AMD is going to be shipping a Helios rack solution, which will contain all of the different hardware pieces from the same vendor, which does remarkably simplify the trust proposition. So now I'm going to take off the advertising hat because I don't really like that job. Okay, so one thing to point out is that I think that this slide is unintentionally a bit disingenuous because the only reason that Microsoft is a part of this chain is because Microsoft, for probably very good reasons, made the architectural decision to put bits inside of the guest, right? If Microsoft does not put bits inside of the guest, And in fact, if all of the bits come from the tenant, which a hypervisor can be designed to do, then Microsoft does not actually have to be in this chain, with the exception of any Microsoft-specific hardware that Microsoft would produce, right? So that's something that I think is critical. Another thing that's really critical to point out here is that while it is true that most of this is complex because of the need to get to the market, there are also some real technical complexities here. So, for example, what precisely it means, for example, to I saw the message and I lost my train of thought. See, we're talking about the technical complexity. So what attestation is rapidly evolving, and there is significant pressure to include more information in the attestation report. This is a pressure that I fight on a day-to-day basis to keep that information out of the attestation report. The reason why is the more information you put in attestation, the more you expect a verifier to be an expert on the things that the verifier is not an expert in. And the more that you do this, the more that you end up centralizing your verifiers. So this remains a problem, but there's already very reasonable requests for things like journey logs inside of attestation. And so we've started off with a fairly simple evidence model, and we're moving to a fairly complex evidence model fairly quickly. The reason why I point this out is that I'm somewhat negative on the opinion of standardization for right now. It's not because I don't like standards. It's not because I don't think they're important, but it's because I don't think we've actually surfaced what attestation actually looks like. Our early attempts, I think, have been naive. Ours, AMD's included, right? I'm not picking it on anybody here. But as the data model sort of unfolds, the needs for that data model are going to be more complex. So anyway, I'll stop talking. But Alec, I really thank you for bringing these issues. This is a necessary presentation, and I really appreciate you being the guinea pig for this. So thank you.
Sure. Thanks for the comments. I agree with everything you set out. I'll look forward to seeing the Helios information. It's the first I've heard of it. So thanks for the pre-announcement. I can't tell the order of things. I think Jens was up first, but Scott, I see you first to my left, so I'm not sure. It's honor system here. Who wants to go?
Mine is relatively fast, and I wanted to just quickly come back to the one evidence piece of the TCB, which became relevant for us, for example, with the recent exposure there was on AMD actually. But shout out to AMD because they work a lot with Coconut SVSM. And in Coconut SVSM, and please correct me if I'm wrong, the TCB attestation is something that you can do completely independently, right? Which is valid for Google at the moment. They have that in preview with Coconut SVSM.
The only line regarding whether you can do the attestation yourself is whether you can efficiently calculate all of the variables that are needed to be verified in the attestation. The more parties that you are composing into the attestation process itself, the more difficult that becomes.
Yeah.
So my understanding is that Coconut provides the security module, which has some important pieces in there. For example, the TPM, the virtual TPM, and it is open source, and Azure is working with Coconut as well, and we're trying to bring in their code as well. But it's not a paravisor. It's just pieces of what we have in our paravisor, the TPM, for example. And Coconut is Linux based. It doesn't help you with Windows VMs. So so there's some bits that are missing in order to make Coconut and Windows be able to party together. So that's on our roadmap, but it's not going to happen soon. Scott, I think you were next.
Sure, thanks. Just to your comments about our attestation evidence. Yeah, to date, we haven't changed our proprietary format on any of our CPUs, what we call the quote. But we are in our future CPU planning to move to standards, to dice-based attestation. So that'll be coming when we can get it. Like you said, it's just slow to get here, especially when you're dealing with silicon. So
Right.
just an FYI for folks.
Awesome. Thank you for that comment. And when that happens, right, anybody who's written a verification service, they're going to have to convert, right, to using Dice, which we all love Dice.
Yes.
But that's why writing your own verification service is cumbersome, right? It gives you a little bit of a smaller TCB, and it does allow you multi-cloud flexibility, but it's work. I think Jens, I didn't know if you had an additional comment or if that's a stale
No, not
hand.
really. No. That was good. That was good.
Oh,
Thank you.
all right, cool. Hank, back to you.
Yeah, so coming back to the verifier being at the heart of all of this, being it as a local or as a service, modularity I think is key here. The verifier behavior must result always in the same output with the same inputs. That's obviously kind of a truth. And we are not exactly there yet. So in order to make that happen, in order to deal with all that heterogeneity and evidence, maybe it will be DICE in the future or something else. Maybe we eat, I don't know. Evidence transformation before it enters the verifier as an actual input is a key mitigation component, I want to say, that solves some of the problems while we still have it. And we might have it for some time. And so the obligation of the evidence provider is to look at a reference verifier that we all agree upon, about a reference by behavior that we can all agree upon, and provide that evidence transformation component. If that would be possible, then it becomes a standard input to the verifier, be it as a service or be it local, again, depending on the password or the backbone check model. And then the obligations of the CSP are basically done. So they have their things. They provide the transformation module. Everybody has and with every, I mean, in the confidential computing domain we are here, where we can maybe agree on a reference verify behavior. And in the ITF with the quorum, we literally smashing that hard with Verizon right now. Verizon really needs, as a project, the reference verify behavior. We are very close to having that. And then I think what someone already called, then there are the bits in the in your guest that are there, which I heard from AMD right now might not be so necessary as we think today. But still, if that would be necessary, you would have to also provide just as an air quote to provide the correct endorsements and reference values for that as the CSP. Again, evidence transformation as a modular thing for the verifier can mitigate some of these problems, I think, if we agree on a common reference verifier behavior.
Hey, Hank, I'm going to ask you a question now. Here's something that I've struggled with just out of ignorance. When we're using TDISP, the CPU initiates the boot, and then let's say they want to bring the GPU into the TCB, and so we use the TDISP to exchange attestation evidence. This is before there's an OS, right? This is before we have a client OS. So the verification has to happen before boot is done, right? It's so early in the boot chain. How do you reach out at that point to the verifier and do the whole attestation before boot happens? And that same question applies when you're trying to decide whether or not to allow the smart NIC into your TCB. I always think of attestation as being something that happens at the very end, but now we have to think about it happening much earlier.
Yeah, well, historically speaking, attestation happened not remote at all. That's called secure boot. The whole protection profile was in the machine. And if the machine started, you know it was good. So now the TPM, for example, not talking about DICE, had all these issues also. The TPM didn't start before some other things already happened. So there was on the motherboard, there's always this static code of just for measurements that would do this early measurements that you can't really get and push out of the system at the end, and would got it handed over by that static code root of trust for measurements, I guess on the motherboard or something, and then has that and goes from there. That's how TPMs do now the authenticated and measured boot when they have a remote verifier, right? So there needs to be a means to acquire that evidence if you really want to look at it. Otherwise, it becomes, and this is called implicit attestation. Implicit attestation means if you get certain evidence from the hardware, so from the platform, then it can only happen if certain conditions have been met. That implicit attestation means a attestation key is only unlocked, so to speak, if some local attestation, like with the TPM I just highlighted from the root of trust of measurement to the TPM, is really working out. And the local protection profile has to be endorsed. That is something you can never see remotely as a client. That has to be something that lives in the endorsement. So the endorsement would say, hey, if you get evidence from this key, you did not see the first half of the appraisal of evidence because that was local, and you have to trust our endorsement that we did this right. That is something that is just inherited from the very, very old program versus secure boot, where it just was all intransparent. So that's the only way to do it. There can be better ways in the future, but I think that will live for a long time. An endorsement of that attestation key that creates the first piece of evidence that can be shipped out from the system to the verifier, that has to be endorsed, unfortunately. Yes.
Got it. Got it. I always wondered how that worked. Thank you for the explanation. I see Jens's hand is still up. I'm not sure if that's a stale hand or if you had another comment, Jens.
Oh, I'm so sorry. I thought I clicked it to get down. It's down for me.
All right, cool. Then maybe it's on my end. Then I don't see any other hands. If nobody else has further comments, I will stop sharing if I can figure out how to do that, and turn it back over to our esteemed chair.
Hey, Alec, this was really a fantastic presentation. It would be great if we could have, if you could broadcast, a copy of the slides, that would be fantastic.
Sure, I just finished this morning, so I'll put it together and I'll send it up. I noticed that all the dignitaries skipped today's meeting, probably because they knew I would be presenting. So once I get back in touch with Ben,
they missed something for sure. Yeah, this was great.
Update the slides. I'm unable to stop sharing for some reason, so I am just going to. I guess I'm going to have to leave the meeting. I've just got a spinning cursor here. Yeah, it's Zoom is dead, so I will join right back.
Okay. Alec, you're back? I can still see his presentation shared, actually.
Yeah, same here.
Can you hear us, Alec?
No, I think he's gone, but I think we may have to all get out and then come back in or something like that, because it looks frozen for. Hey, Alec is back, but the ghost of Alec, the former Alec is still there. So I think we need to get out and come back in.
We can't hear you either, Alec.
I guess my presentation broke Zoom.
So here we go. Here we go.
Okay,
it's done now. It's done. It took a little bit of
your voice
time to yeah. You had to recognize that you were there twice. Yeah.
Awesome. Well, the zombie of me lives on. All right, I'll go back on mute now on purpose this time and turn it back over to our esteemed rotating chair.
Yeah, I did have a question actually about the last slide. So given the fact that we are living today in a world where bits and pieces from the cloud are within the trust boundary of the confidential VM, the question is, what would be necessary to be okay with that currently? You mentioned transparency. That's what comes to my mind when I think about this being okay. At least the reference gold measurements need to be publicly available for anybody to verify at any time, so that at least I'm not targeted by a particular cloud provider for some sort of attack. Is that enough? Is that enough as a measure today to claim that if UEFI or whatever other firmware is provided by the cloud provider or the paravisor, is it enough for me to feel okay that the confidential computer threat model is not broken just because I fetched what reference measurements should be from the transparency log that I like? Or should we even push it further into just this is beyond measurements? Maybe some other third party that I trust should have audited it.
I'll let Hank go, but what he said about transparency earlier, I think is the key. But Hank, you've got your hand up. Please go.
Yeah, so exactly. So transparency literally is key here. Transparency services such as the SCID transparency services or Recor from Google, I hope version 2. Then these have to collaborate. So you put your reference values and endorsements, hopefully in the standard composable format for the verifier, on that transparency service, so you cannot take it back. Microsoft, AMD, Google Cloud have said those things, and then there needs to be of course, this is just the I want to use the term e-notary. I know that notaries not always work like that, but they don't keep the contract. So it's just making sure that this has been set and getting a receipt for it, like an inclusion proof from a hash tree or something, and then you need to have a silo that is accessible next to it that can be distributed with all the CSPs or whatever, and that is in the receipt that you get back from the tree. So in this inclusion proof, there should be something like, and by the way, this included thing lives here, and there's a URL. And then if you have such infrastructure, you can audit this. And some other, depending on the registration policy of the transparency service, again, be it SCID or Recor or whatever, then you can have the policy that also other entities can audit it and say, no, these reference values are not good. And they have to be associated with that, and that needs a overhead. There's some API here that I'm talking about that has never been standardized. Everybody's doing it themselves, but putting all these reference values and endorsements on your homepage, I want to call it that, an IT's term, is not the solution. Witnesses and a set of organizations that all agree that this is too important not to disagree on, to collaborate on the transparency of what we say, to keep the things confidential between even competitors and markets. That's critical here, I think. Yes.
Yeah, thank you. I think that's understood that, well-implemented transparency log and the ability to fetch and audit whatever you're getting from them is necessary. I think I'm asking the question because if we have today bits in the CVMs, should we, as attack and the CCC, have an explicit opinion about the need to have golden measurements in transparency logs for it to meet what we consider as the standard definition of confidential computing? Because it is not in this forum. A lot of people are aware of this. Outside of this forum, it is not a concept that a lot are familiar with. And if we are to want to have good implementations of CC technologies everywhere in the enterprise, not just in the public clouds, it is necessary that these concepts are articulated clearly to the adopters of the technology. So I'm putting it forward as, future need for us to tackle. I want to hear from Nathaniel, who's had his hand up for this topic. Go ahead, please.
Yeah, so I'm going to offer a contrarian opinion because that's what I do, I guess. Let me distinguish between three terms because I think that it will help to elucidate the problem. So one is open source, right? That is, the bits that are in the guest need to be open source in order to validate them. Open source and probably reproducibility of that open source is a necessary prerequisite for the next term, which is transparency. Transparency usually implies something like transparency logs, which we're discussing here. And then there is a third term, which I'm going to call operational control. Okay. both operational control and transparency depend upon open source. So I am absolutely advocating for open source, reproducibility, and all of those things. However, transparency logs are the wrong solution, in my opinion, for this problem. They're the wrong solution precisely because they don't solve the core issue, which is the question of operational control. What's going to happen if you go down the transparency log event is A, your verifiers got more stuff to do now. And verifiers are already overloaded and overcomplex as they are. Okay, that's problem number one. Problem number two that's going to arise, however, is that the transparency log is not actually going to solve the operational control problem. There are two concrete examples of this. The first example of this is when there is a vulnerability that has been known, but it's still under embargo. So what's going to happen is because the tenant does not have those bits under its operational control and the host platform does, the host platform is going to deploy a set of bits that are going to go into the guest, and those bits cannot be disclosed, right? The open source for them cannot be disclosed, and you've broken any ability to do reproducibility. So that's problem number one. But problem number two is when there is a vulnerability and there is a fix, but the host has not operationally applied the fix to their cluster, right? So this could happen, for example, if there's a 0-day where we might have a fix, but the cloud cannot deploy that fix at scale because it needs to qualify it, it needs time to test it, et cetera, right? All of those kinds of things. And so in the meantime, every tenant is now vulnerable to this 0-day because the bits that is the term I keep using are under the operational control of the host. So the only real solution to this problem is that we have to move the operational control of those bits from the host to the tenant. It is the tenant who can be part of the embargo window and who knows exactly what those bits are and can ship them, and it is precisely the tenant who knows which vulnerabilities are of concern, etc. So in my opinion, we absolutely need open source no matter what way we go. I'm absolutely advocating for that, but I'm also advocating for a model where the operational control of those bits in the guest are owned by the tenant.
Thank you, Nathaniel. I want to hear from Alec first. Go ahead, please.
Nathaniel, I agree with you in principle, but there's a problem, and that is two things. One is, as you mentioned, when we're under embargo and there's a 0-day, as a cloud service provider, you have a responsibility to patch those bits as quickly as possible, and you're legally obligated to not disclose the vulnerability until after the patch is in place, right?
Not if you don't distribute those bits, right? The only reason you're in that problem is because you have chosen to supply those bits to the guest. But if they're supplied by the tenants, then it's not your problem. You have no legal responsibility because you don't own that domain. Whatever is inside of the guest is entirely and wholly the guest's responsibility.
I agree, but there are some bits that are kind of in the shared responsibility model. There's some bits that are, for example, firmware that I have to apply because it's provided, it's in my infrastructure. I'm a cloud service provider. I have to patch the firmware. Well, hang on, let me finish my conversation. There's the problem of who's legally responsible to apply the patch. Do you want to force an outage? In other words, shut down every VM in the cloud and tell the customers, hey, sorry, we didn't mean to shut down all your workloads, but until you agree to absorb this security patch, we're not going to allow you to restart your VMs. That's obviously a non-starter. So you've got these problems where you're kind of obligated to apply patches without the tenant's consent unless you shut them down. So that's a problem. And there's one other problem, and that is that the complexity. If let's say we have bits inside of some VMs, right? In the case of the Paravisor, if Microsoft has bits in some VMs, if we allow different customers to opt in to to adopting the patched versions, then we would have to have the complexity of managing N versions of the Paravisor, for example, across our cloud infrastructure. And the complexity of doing that right now is daunting because we have to be able to maintain the fleet at some par of different versions of all the interacting software. So we're kind of in a situation, and I think all cloud service providers are in a situation where they have to have the same hypervisor on all the nodes. They have to have the same paravisor on all the nodes. And there has to be hardware compatibility across the fleet. And those things are make it very difficult to allow individual tenants to control which versions of bits they have in their CVMs or their Ts of whatever sort.
So all of those conclusions logically hold if you start with the premise that there must be shared bits. I'm arguing that that premise is false. I'm arguing that that premise is false because I've implemented it in the past, and also I have a hypervisor sitting on my laptop that I have not yet disclosed that does precisely this. It has no shared bits whatsoever. So if that assumption is not true, then none of the conclusions that you have arrived at actually hold. Because if it is possible to have a hypervisor that has no shared bits whatsoever, where shared bits is executable code, there is some minor data that has to be shared. But if there's no code that has to be shared between the hypervisor and the guest, and if you can have some versioning protocol on that, then it becomes entirely the tenant's responsibility. So the reason why the industry has not gone that way is because historically we have not built hypervisors that way, and we just simply haven't architected it.
Hank, you can go ahead.
Yeah, I want to give time to somebody to respond here to Nathaniel before I say my piece, if there's any.
I think my comment was to Nathaniel's point, which is interestingly, yes, I agree that there should be minimal shared code between the hypervisor and the CVM if we are to take seriously the CVM threat model. But I also understand the operational complexity of having tenant control. Let's just forget about the paravisor. Like somebody might elect not to use it and Azure is okay with it, but tenant controlled firmware, like although that would be something very exciting for ISVs building confidential stuff on Azure CVMs. And I have seen, I think 3-4 years ago, an initiative from Azure, which for us at Canonical was extremely ambitious and very exciting. It was bring your own firmware. And there was a nice layout of an understanding from Azure that people can decide on the operational. First of all, they can choose from a set of firmware that they want to run or bring their own as long as it satisfies a certain ABI between them and the hypervisor. But also they had the option to choose the operational control that they would want to have over the firmware. So that was before even the paravisor was a thing for Azure. And that seemed like a direction that ultimately we would want to move towards. I understand that today is a bit more complex operationally, but I think it would be very good. I'm perhaps speaking here from the end user's perspective, which as an OS provider, I think we speak to quite often because they need us to do special stuff for their OS images. But that's something that would be very much appreciated by people who worry about giving guarantees that are based on confidential computing to their end users. So I'm not sure how ready the clouds are or how soon we can get to that future. But I do acknowledge, and I join Nathaniel, is that these assumptions do not have to stay the assumptions forever. The VMM can be another type of VMM that doesn't hand over stuff to the tenant, and the tenants can be more empowered from a security perspective. But also, it means they have to be responsible more for their ops. It comes with the deal. Alec, if you want to respond to this, I think you can go ahead before Hank.
Well, the only thing I was going to say is I don't understand the model that Nathaniel put out. If it implies every tenant is running their own hypervisor, then the cost of having individual hypervisors would be passed along to the tenants as, leased memory space. So that's an interesting proposition right now. The hypervisor is kind of considered a commodity, and everybody gets it for free. But if you had individual hypervisors per tenant, that would be interesting and would have an interesting cost component to it. But that's something that I've never really thought about. I've always thought of the hypervisors kind of like being, just infrastructure that's shared by all. So that's one thing I'll say.
That's not the architecture. The architecture is that the hypervisor has to have essentially a bring up protocol that can be well defined, and then it becomes passive to the tenant who describes to the host exactly how it wants the guest set up. Right. So once you have that protocol in place, then all of the rest of the interesting stuff happens on the tenant side.
That sounds really cool. I'll look forward to hearing about that. And as far as custom firmware, that is something, as you've seen, Ijal, we've moved to open sourcing our VMM. We're trying very hard to get open source and transparency around every bit that we introduce into customers' T's. So, we're all part of OCP and SAFE, and we're trying to get open source roots of trust. We want every single bit to be open source, reproducible, maybe after the fact, right? For the reasons that we discussed earlier with 0 days. And that gets back to Hank's, if you've got a trustworthy ledger with build measurements, then you can think about SLAs where you can't reproduce the bits prior to starting your workload, but there would be an SLA where 30 days after an update was announced, the source was posted, the measurement was posted, and then you could see that the code that you got injected into your TEE 30 days ago to patch a vulnerability is now posted, is now open source, and you can verify it. So it doesn't prevent the cloud service provider from introducing code ahead of time. But if we introduce any code that's got serious security vulnerabilities, accidental or intentional, that would become obvious within 30 days. So I think that would add to transparency and trustworthiness. I think that's the North Star and if you read that article, Why Should I Trust Your Code? You'll see that that's the North Star. And
quick comment on this. Open source obviously is very important, but it might be the case that people have other trade-offs for the boots that they want to optimize for. So not everybody is very excited necessarily about having UEFI firmware on their CVMs. That's pretty heavy for a virtualized environment. It makes a lot of sense for devices, etc. So these are maybe they want a super fast boot time that cannot be met by having a full paravisor plus a VMF as a boot choice for them. So these are the type of things that would be still interesting to aim for, on top of everything being open source, which very much it's a very much appreciated move from the public cloud providers, of course.
And Direct Linux Boot is not incompatible with transparency and with open source. That's something that we're very much interested in pursuing.
Okay, very cool to hear. Yes, Hank.
Yeah, okay. So I think open source is one big strategy that leads to better future. Okay, I think we all agree on that. I want to quickly comment on the cost and burden of reproducibility and the cost and burden of transparency. So having been privy to reproducible builds for firmware, that is a huge effort. And nothing is reproducible from on GitHub. Nothing is. Compiler flags, timestamps, the platform you build on. I've seen network equipment vendors struggle with this for years, how to make, not for our customers, but internally for quality assurance, their firmware builds reproducible. And it is a huge cost, which every single new bit. And so it's a little bit hard to, and maybe we mean different things with reproducible here, but I want to say it's a very hard cost. And that can't be simply distributed. Someone has to lift that weight. And then down the burden and cost of transparency, that's relatively small, actually, if you trust the transparency service. Now, of course, this is just moving the problem away from the CSP to the transparency service. You could say, sure, but transparency service have the feature of being transparent. So everybody can look at their other thing, and there might be multiple, and there can be consensus on this, and there might be a thing. But also, when you put something on this transparency service, we call this the thing you get back, a receipt. It's like not only the inclusion proof, but it's also metadata that you can put trust into. So on the verifier side, it might be enough to trust the receipt. You do not have to do a manual audit trail every time you do a evidence appraisal. You can check the receipts for the inputs that are reference values, endorsements, and maybe even policies sometimes, I don't know, and then go with that. And that would reduce the burden of appraisal significantly because those are tiny. These receipts are tiny and scale hard. And thereby, I think some of the issues you were highlighting with the transparency service are already mitigated. But I, of course, admit it becomes way more difficult if you want to bring reproducibility into the picture.
Okay, I want to thank everybody for the excellent, lively comments and feedback on the presentation. Alec, thank you for the presentation. I want to propose that this format of a tech talk that brings a topic of conversation seems to be very useful. So if you don't have to have a solution for the topics you want to present, just a question that you think would be interesting to the audience would be a good way to have more tech talks. So for next time, we do not have a topic yet. If there is, VMM seems to be something that we could discuss. What does it mean to have a modern VMM for confidential computing? What do we want ideally from our boot firmware software to look like in confidential VMs could be another topic. But please do send me then such ideas and we can work on organizing them into tech talks for future sessions.